Hello students, once again welcome to the engineering chemistry course. Before starting the today's lecture, just have the recap of the previous class. In the last class we have started with the unit 3rd corrosion, in which we have learned about the definition and introduction about the corrosion, disadvantages of corrosion, and then we started with the theories of corrosion, in which we have learned that there are three theories given for the explanation of corrosion: acid attack theory, chemical attack theory, and the electrochemical theory. Out of these three theories, we have discussed in detail the two theories, acid attack theory and the chemical attack theory, in our last class. So today we are going to discuss with the electrochemical theory of corrosion or the wet corrosion. Basically, the electrochemical theory is the most widely accepted theory for the explanation of wet corrosion. Wet corrosion means corrosion in presence of moisture. It is also called wet or the immersed corrosion. This type of corrosion takes place under two following conditions. Very important these conditions are: first is the when a conducting liquid is in contact with the metal. Second condition, when two dissimilar metals or alloys are either immersed or dipped partially in the solution. So what are these two conditions? First condition is when a single metal is in contact with the conducting liquid, that means electrolyte solution. Second, when two dissimilar metals are in contact of each other and they are partially immersed in a electrolyte solution. Any of the condition may cause the corrosion. Why? Because in such conditions, the metal surface becomes chemically non-uniform and small anodic and cathodic area are developed on the surface of the metal, due to which the metal surface behave like a small galvanic cell, and corrosion takes place through the electrochemical reaction. That's why it is called electrochemical corrosion in presence of the moisture. So basically, what important things here we are going to discuss? First thing, in any one condition out of these two conditions, in any one of these conditions, actually the metallic surface becomes chemically non-uniform. When metal surface becomes chemically non-uniform, there will be the formation of anodic and cathodic area onto the metal surface, and due to the formation of these anodic and cathodic area onto the metal surface now behaves like a small galvanic cell, and the corrosion reaction takes place through the electrochemical phenomena, electrochemical reaction. That's why it is called the electrochemical corrosion. So first you must remember this thing, that in any of these conditions, the metal surface becomes chemically non-uniform. As the metal surface becomes chemically non-uniform, there will be the formation of anodic and the cathodic area, due to which corrosion reaction takes place through the electrochemical reaction. That's why it is called electrochemical corrosion. Now, if we understood the concept of the process or the initiation of the electrochemical corrosion, now let us move towards the mechanism of the electrochemical corrosion or the wet corrosion. So, as the metal surface become chemically non-uniform and there is the formation of a small galvanic cell at the metal surface, then corrosion takes place in three steps. First is the formation of cathodic and anodic area on the metal surface. Second, flow of electrons between cathode and anode. Third, formation of corrosion product between anode and cathode. So you must remember these three F. What these three F's here? First F is the formation of anodic and cathodic area on the metal surface. Second F, flow of electron between anode and cathode. Third F, formation of corrosion product between anode and cathode. So, you must remember that if the metal surface is present in any one of these conditions, then due to these conditions, metallic surface becomes chemically non-uniform and corrosion takes place. Why corrosion takes place? Because as the metal surface becomes chemically non-uniform, there will be the formation of anodic and cathodic area. As the cathodic and anodic area formed onto the metal surface, second step, flow of electronic current started between these two areas, and as the electron flow started, third step, that is the formation of corrosion product, takes place. So in presence of these two conditions, metallic surface undergoes corrosion through the electrochemical reaction. So I hope you must understood the concept of the electrochemical corrosion. Now let us look the mechanism of the electrochemical corrosion. As just now I shared you that when the metal surface becomes chemically non-uniform, there will be the formation of anodic area and the cathodic area. One thing you must note that always corrosion takes place at the anodic part only. There will be no condition, no situation when corrosion of cathodic part takes place. Never. It never possible that corrosion of the cathodic part takes place. Why? Because we know that the corrosion is the conversion of metal to its compound. That means metal must undergo into oxidation reaction. So this is the oxidation reaction, and we know that oxidation takes place only at the anode. Therefore, corrosion takes place at the anodic part only, not at the cathodic part. So you must remember that corrosion always takes place at the anodic area, right? So first of all, when metallic surface becomes chemically non-uniform, there will be the formation of the anodic and the cathodic area. As the cathodic and anodic area formed, second step is started, in which release of electron, formation of electrons, flow of electrons is started between anode and cathode. Now at anodic part of the metal surface, the metal atom converted into metal ions and the electrons are released, because at this part which reaction taking place? Oxidation of metal. Due to this oxidation of metal, electrons are released. So always anodic reaction is fixed. At the anodic part always oxidation takes place, and oxidation is the conversion of metal into its cations with the release of the electrons. So this is the oxidation reactions taking place at the anodic part. Now second is the cathodic reaction. Cathodic reaction is what? At the cathodic reaction, reduction takes place. The electrons released at the anodic part are now consumed at the cathodic part. So at the cathodic part, reduction takes place. Reduction is the consumption of the electrons released at the anodic part. So these electrons must flow from anode to cathode. So there is the flow of electron. Our second step, flow of electron between anode to cathode started, and electrons are now moved towards the cathodic part. Now at the cathodic part, consumption of these electrons takes place in the reduction reaction. This consumption or the reduction process at cathodic part is dependent on the surrounding medium. What it means, the surrounding medium? The metal is present in which type of environment. It may be acidic environment, or it may be basic or the neutral environment. So further cathodic reaction depends upon the surrounding medium. In case metal is present in the acidic environment, then cathodic reaction is the evolution of hydrogen, while the metal is present in the basic or the neutral medium, then the cathodic reaction is the absorption of oxygen. So I hope it is clear to all of you now that as the metal surface becomes chemically non-uniform, there will be the formation of anodic and cathodic area. At the anodic part, always oxidation takes place, and due to the oxidation of metal atoms, metallic cations are released and electrons are also released. These electrons are now flow towards the cathodic side. At the cathodic part, reduction reaction taking place, and this reduction reaction depends upon the surrounding medium of the metal. If the surrounding medium is acidic, then at the cathodic part evolution of hydrogen takes place, while if the metal is present in the basic or neutral medium, then absorption of oxygen takes place at the cathode. So let us discuss one by one both the cases. Now, first case is the when metal is present in the acidic environment. Suppose this is our metallic structure. This is the metallic structure, right? This one, our metal. Suppose this is the iron metallic structure. If at this metallic structure some acid drop is present here. So which type of medium, which type of environment here? Acidic environment, because acid drop is present here. So due to the presence of this acid drop, the metallic surface is now become chemically non-uniform. How? Because two types of metallic surfaces are there. First surface is this where acid drop is not present. Second surface is this where acid drop is present. So metallic surface becomes chemically non-uniform. The surface area where the acidic drop is not present, that means where the iron metal is directly in contact with the environment, is called the anodic area, while the area where the acid drop is present is called the cathodic area. So as the metal surface comes in the contact of the acid drop, the metallic surface becomes chemically non-uniform. There will be two types of areas are formed. One is the large area, anodic area, where acid drop is not present, while second one is the smaller cathodic area where the acid drop is present. So now what happens next? At the anodic area, as we discussed, always oxidation takes place. So at the anodic area, iron atoms converted into iron plus 2 ions and the electrons are released. So oxidation takes place at this large anodic area. And in this oxidation reaction, electrons are released. The electrons which are released at the anodic area now move towards the cathodic area. Why these moves towards the cathodic area? Because at the cathodic area acid drop is there, and we know in acid drops always protons are there. That means H plus ions are there at the cathodic area. So since H plus ion is there at the cathodic area, so these H plus ion attracts the electrons from the anodic area. So electrons move from anode to the cathode in this direction. So flow of electrons are started between anodic to cathodic area. Now third step is the reduction at the cathodic part. So what reduction taking place? These electrons are consumed by the protons of acid, and these protons get converted in the hydrogen gas at the cathodic part. So overall we can say in presence of acidic environment, anodic reaction is iron converted into iron plus 2 and electrons are released. The electrons which are released at the anodic area now move towards the cathodic area, and at the cathodic area the H plus ions from the acid reacted with these electrons and converted into the hydrogen gas. So at the cathodic area hydrogen gas is evolved, right? So overall reaction we can write it as iron with reaction of the acid converted into iron plus 2 ions, and hydrogen gas is released at the cathodic area. So once again come here, in presence of acidic environment at the cathodic part, what reaction taking place? Evolution of hydrogen. Now you can easily understand how at the cathodic area in presence of acid hydrogen gas is evolved. Clear? Next condition, in presence of neutral or the basic environment. So one example here of the neutral or the basic environment is, suppose this is the metallic structure or any metallic article here, iron metallic article, this is the iron surface. Now we know iron can easily react with the oxygen. Due to this reaction, there is the formation of the oxide layer onto the metallic surface. In this way, oxide layer is formed. But this oxide layer is the porous layer. That means some spaces are there present at the metal surface which are not covered by the oxide layer, right? So due to this porosity of the oxide layer, the chemical surface of metal becomes chemically non-uniform. One is the area which is covered by the oxide layer. Second is the area which is not covered by the oxide layer. So the area at which metal surface is in direct contact with the environment is the anodic area. This is the anodic area, while the other large area which is covered by the oxide layer is the cathodic area. Clear? So first understood the case of the neutral or the basic environment. In case metal surface is present in the neutral environment in presence of the aqueous neutral solution. So in this case, normally at the iron metal surface oxide film is formed, but the nature of the oxide film is porous. So this layer is the porous. Some part are there remained uncovered through the oxide layer. These parts suppose I denote by the number 2 and the covered part is denoted by number 1. So the uncovered part, that means the pores part where the pores are present. So this part is the small part and this is the anodic part because it is in the direct contact with the environment. Otherwise this remaining part is the cathodic part. So chemical non-uniformity create the anodic part and the cathodic part here. Okay. So at the anodic part, as always, oxidation takes place. In oxidation, iron converted into iron plus 2 ions and electrons are released. Always at the anodic part, oxidation takes place. So the electrons released at the anodic part now move towards the cathodic part. Okay. At the cathodic part, these electrons are consumed by the oxygen, and oxygen in presence of moisture or the aqueous solution converted into the hydroxide ions at the cathodic part. So this is the reduction reaction taking place at the cathodic part. So in all, in the acid neutral or the basic environment, anodic reaction is the same, that is oxidation of the iron plus 2 ions and electrons are released. These electrons are get consumed at the cathodic area. At the cathodic area, oxygen consumes these electrons in presence of moisture and generates the hydroxide ions at the cathodic part. Now look at here, at the anodic part iron plus 2 ions, and at the cathodic part OH minus ion are there. Here Fe plus 2 ions are generated at the anodic part, while at the cathodic part OH minus ions are generated. Both the ions are having opposite charge. So these ion moves towards each other. Fe plus 2 attracts OH minus and OH minus attracts Fe plus 2. So these ions moving towards each other and combine with each other and forms the iron hydroxide. If enough oxygen is present, then this iron hydroxide get converted into the iron rust, yellow colored iron rust, Fe2O3.H2O. If less amount of hydrogen is present, the corrosion product may be the black Fe3O4. So basically, if iron metal is present in the environment which is the neutral or the basic environment, then at the cathodic part absorption of oxygen takes place. Look here again. If the metal surface is present in the basic or neutral medium, what reaction taking place at cathode? That is the absorption of oxygen, and this absorption releases the hydroxyl ion at the cathodic part, which ultimately combines with the Fe plus 2 ions and forms the iron rust. I hope it is clear to all of you now, both the processes. So anodic reaction is always the same, that is Fe gives Fe plus 2 electrons, but the cathodic reaction depends upon the medium. If metal is present in the acidic environment, that at the cathodic part hydrogen evolution takes place, while the metal is present in the neutral or the basic environment, then at the cathodic part oxygen is absorbed and finally iron rust is formed near the cathodic area. Clear? Now look again here in both the diagrams. Look here. Here the cathodic area is small and anodic area is larger, right? While in the basic medium anodic area is smaller and cathodic area is larger. Focus on that point. I will come again on this point in my next lecture. Okay, so it is a revision time now. What we have discussed today? Today we have discussed the most widely accepted theory for explanation of the corrosion, that is the electrochemical theory, which is also known as the wet corrosion theory of the explanation for the corrosion. According to this theory, corrosion of metal taking place under two conditions, either of two conditions actually. First is the when metal is in contact with any conducting liquid, that means electrolyte solution, or the metal is in contact with another metal, that means two dissimilar metals are in contact with each other and either immersed or dipped partially in an electrolyte solution. That means two metals are in contact with each other and also in contact with the electrolyte solution. In either of the case, what happens? Actually, in such condition, the metallic surface becomes chemically non-uniform, due to which at the metal surface anodic and cathodic area formed and metal surface behaves like small galvanic cell and corrosion takes place through the electrochemical reaction in presence of moisture. So this is the basic concept, and after that we have discussed that as the metallic surface become chemically non-uniform, cathodic and anodic areas formed, then at the anodic part oxidation of metal takes place, due to which electrons are released. These electrons are consumed at the cathodic part. So second step is the flow of electrons between anode to cathode, because electrons are released at anodic part but consumed at the cathodic part. And third is the formation of the corrosion product between anode and cathode. So that's all for the today's class. Now it's time for the learning check. I'm leaving this lecture with the question, why corrosion rate is higher in case of a smaller anodic area. Look at again here at this diagram. First condition, when acid drop is present at the metallic surface. In such case, anodic area is large and cathodic area is small. While in second case, anodic area is small and cathodic area is large. My question is, why it happens that when corrosion when the anodic area is smaller, the rate of corrosion is higher? Think about this question and we will discuss the answer of this question in next live class tomorrow. Okay? Till then, take good care of yourself and keep enjoy e-learning at home. Thank you.